Okay, so one more sample problem to look at. We've looked at one growth problem, we've looked at one decay problem. In both of those, the model was given to us already set up. In this one, we are not given the equation. We have got to set it up ourselves. All right, so let's work on this one together. So a bacteria population follows the law of uninhibited growth. That means exponential growth and decay. That's this model. The sample starts with 500 bacteria and has 800 bacteria in 4 hours. How many bacteria will it have in 8 hours? Okay, so we need to set up our equation and then we can answer this question. We've seen the same idea over and over again. Okay, we set up the equation. We're going to use what we know to get this equation set up, and then we're going to go back and answer the question. Okay, so let's work on getting this set up first. So what do we know? The sample starts with 500 bacteria. So where do I put that? That's our initial amount. And so that means that it is A naught. Okay, our initial amount is A naught. All right, so we have A of t is equal to 500 e to the kt. Okay, we know that that initial amount's not going to change, so we can go ahead and put that 500 in, and that's going to stay the same the whole problem. All right, now we don't know our rate. This was given to us in all of the other problems. We don't know our rate. But this time, we can use what we know to find that rate. So we've got to find the two numbers that go together. Remember this from, we've seen this before, okay? We've done linear models, we've done exponential models, we did variation. This was the same thing. Find the numbers that go together, an x and y value, to figure out the missing one. We need this rate. So we know that we have an amount and a time that go together. So let's use what we know to find k. Okay, use what you know to find k. All right, so we're going to put in 800 equals 500 e to the k times 4. So I put the 800 in for A, I put 4 in for T, and we're going to solve for K. Now if you look at this, okay, we're doing K this time, but it's really the same as the ones that we just solved looking for T. It's just a different letter. So it's the same exact steps. We need to get the exponential by itself, and then we need to take a logarithm. Okay, so let's get the exponential by itself. We divide by 500. So we get 800 over 500 equals e to the 4k. 4k. And then we take a log on both sides. We're going to take natural log. So we got natural log of 800 over 500 equals natural log of e to the 4k. Natural log and e cancel out, which is what we're hoping for. And we're going to have natural log of 800 over 500 equals 4k. We're trying to get to k, so we divide everything by 4. Okay, so we want natural log of 800 over 500 divided by 4. We're going to put that in our calculator carefully, and you should get 0. Let's do 1175. This one you want to try to keep 3 decimal places. The more decimal places you keep, the closer your answer will be to accurate. So I would do 0.1175 or 0.118 at the best. Okay, you round this one to 2 decimal places, it may make it a little bit hard, but you can if you want. It just might not match the book exactly. Okay, so now we've got our initial amount, we've got our rate, so we have got the setup to our equation. We've got A of t equals 500 e to the 0.118 t. I'm going to go ahead and use 0.118 because it's small print, I mean. Okay, so this was all just to get the setup for the equation. Okay, so let's go back. Let's get rid of all this stuff. Okay, so now where are we? We've got our equation. I'm going to rewrite it over here so we're back in the middle of the screen. So we've got 500 e to the 0.118t. Okay, probably read that a little bit better there. All right, so now what do? We set up the equation. Now we should be able to answer whatever question they throw at us, just like we did in the last two problems. So the question is, how many bacteria will it have in 8 hours? How many bacteria will it have in 8 hours? So this is a time. So we can take our time and we can plug it into our equation here. So when we plug in 8, we're going to plug it in right there. We're going to put this into our calculator. Let me do that real quick. E to the power of 8 times 8. Okay, so we plug that into the calculator and we get 1285.12. And remember, this is a population. These are living things. So we'll go ahead and make that 1285. Okay, now if you had done this same exact problem and you had done 0.1175, let me calculate that real quick. You would have gotten 1280. When you round that, you would have gotten 1280. And if you had rounded to 0.112, I'm sorry, 0.12. 0.12 would be if you rounded 2 decimal places. You would have gotten 1306. Okay, so depending on how you round some of these numbers, your answers can vary a little bit. So if you're like maybe plus or minus 10, 15 or so, it's probably a difference from, like from the back of the book, it's probably a difference in rounding. If you're more off than that, like if you're like, let's say it's 1285 and you got 1390 or you got like 1005, then maybe something went wrong. But if you're seeing differences like this between your homework and the back of the book, it's probably just a difference in rounding. And you can always ask me and say, hey, did I do this right? Because my answer was a little bit different, and that's fine too.